Continuing to present this diagram that's going to enable us to divide the circle perfectly into 360 degrees, and from there we're going to look at what I consider to be the base 12 version of pi. So in the last few videos I've introduced you to a dodecagon that's formed by literally connecting the dots or specific points on the base 12 version of the Cartesian plane. The first point we're going to look at is this one here that has the x coordinate of 1.1. And the next point is we go over 1 and up the length of 0.7. So it's these 2 points, and then the same here, sort of in reverse, that we're going to use to draw 2 circles now and just see what the radiuses are of those 2 circles. We're going to create something of a ring, because these aren't the same distance from the point 0, 0. So we've already calculated this hypotenuse of this triangle to be the length of the square root of 1.41. And then 1.1 squared gives us a radius of the square root of 1.21. So if we want to find the area of this ring that we've just created by drawing those 2 circles, we use the formula for pi r squared. We're squaring our radiuses and subtracting one from the other. We get an answer of the square root, or just 0.2 pi. So 0.2 pi is the area of this ring. So now what we want to do is draw another circle right in the center of that, with the radius of 0.96 root 2. So that's the point where our 45-degree line is intersecting this 0.5 root 2 radius circle that's perpendicular to that line. Both of these lines are in units of the square root of 2. We're going to be building our entire diagram out of units of square root of 2. That gives us the irrationality with which we can then build a fairly rationally balanced symmetrical diagram for the 360 degrees. So 0.96 squared is 0.763, so square root of that times square root of 2, square root of 1.306. So what's the difference between the areas of these 2 rings now that sort of make up the 2 halves of the larger ring with the area of 0.2 pi? So we start subtracting one from the other. We get an outer ring with the area of 0.106 pi, and then an inner ring of 0.0L6 pi. So we can subtract the smaller one from the larger one, and the difference between these 2 rings is an area of 0.01 pi. So I just wanted to show you all that, just show you that this structure has a lot of very simple, basic, origins. 0.2 pi, 0.01 pi is emerging from just connecting these dots and drawing some circles. That's the seed. This is the seed, or the very inner structure from which we're going to build this entire diagram for 360 degrees.